So the data that just came out is absolutely wild. SpaceX Starlink satellites had to dodge other objects 144,000 times in just 6 months. 140,000 collision avoidance maneuvers. That works out to one dodge every 90 seconds. But here's what makes this number truly disturbing. 6 months before that, the total was only 50,000 maneuvers. So in half a year, the number tripled. And when something triples every 6 months, you very quickly get to completely unmanageable numbers. Before we dive deeper, you might be wondering why companies are even launching this many satellites. Well, the main goal is global internet coverage. SpaceX wants high-speed internet in every corner of Earth, including remote areas with no infrastructure. That requires satellites close to Earth for low signal delay and thousands of them covering different zones as they orbit. Traditional satellite internet used maybe a dozen satellites in high orbits. Starlink uses thousands in low orbit. And it is not just SpaceX. China wants the same thing. So does Amazon. So does OneWeb. Everyone is racing to build these mega constellations. But nobody really thought through what happens when you pack thousands of satellites into the same orbital zone. Here's how fast this happened. In 2015, there were about 1,300 active satellites orbiting Earth total. That includes every country and every company. By October 2025, that number reached 13,000 active satellites. We went from 1,000 to 13,000 in just 10 years. Most of that growth happened in the last 5 years. 57% of all objects ever launched into space have been launched since 2020. The mega constellation era basically started in May 2019, when SpaceX deployed their first big batch of 60 Starlink satellites. Today, Starlink alone operates around 9,400 satellites. So, why are satellite collisions so catastrophic? Well, these satellites are moving at 28,000 kilometers per hour. That is 8 kilometers every single second. At that speed, you could cross the entire United States in 10 minutes. When two satellites traveling in different directions collide, their combined impact velocity can exceed 50,000 kilometers per hour. At those speeds, a collision does not just dent the satellites, it vaporizes them. A typical small satellite weighs around 200 kilograms. When it crashes at orbital velocity, the kinetic energy released equals 4,000 kilograms of TNT exploding. Both satellites get torn into thousands of pieces. Each piece becomes a new bullet flying through space at speeds that would cross a city in seconds. And we actually kind of know what this looks like because it has happened before. Back in 2009, a working American communications satellite called Iridium 33 accidentally crashed into a dead Russian military satellite called Cosmos 2251. The impact velocity was over 42,000 kilometers per hour. The explosion created over 2,000 pieces of debris, large enough for our tracking systems to detect. Scientists estimate the actual total was tens of thousands of fragments, including all the pieces too small for radar to see. 15 years later, more than 1,000 of those trackable fragments are still up there traveling at lethal velocities. Some will stay in orbit until the end of this century. And that was just 2 satellites colliding. Now we have over 9,000 Starlink satellites packed into similar orbital zones, plus thousands more from other companies. This brings us to the nightmare scenario called Kessler syndrome. When enough satellites and debris occupy the same space, collisions become inevitable. Each collision creates thousands of new fragments. Those fragments spread out into crossing orbits. Eventually, fragments start hitting other satellites. Those collisions create even more fragments. The collisions start feeding themselves in a runaway chain reaction. And when that happens, entire altitude bands become unusable. Anything you launch into that zone just gets shredded by the debris cloud, and it stays that way for decades or even centuries, depending on the altitude. And here is what that actually means for everyone on Earth. We rely on satellites for GPS navigation, for weather forecasting, for internet and communications, for monitoring climate and disasters. If we lose access to key orbital zones, those services degrade or fail. Your phone GPS stops working accurately, weather predictions get less reliable, internet coverage drops in remote areas. Emergency response systems that depend on satellite data lose capability. Scientists used to think Kessler syndrome was a distant future problem, but the math is changing fast. Researchers just published something called the crash clock to measure how close we are to disaster. It calculates how long we have before a likely collision if all dodging suddenly stopped. Back in January 2018, before mega constellations existed, the answer was 121 days. The satellites were spread out enough that even with zero collision avoidance, it would take about 4 months before two objects randomly hit each other. Today, that number is 2.8 days. If every satellite stopped dodging right now, we would probably see our first catastrophic collision within 72 hours. Within 24 hours, there is a 30% probability of a crash somewhere. The safety margin collapsed by 43 times in only 7 years. So, how does the dodging system actually work? Understanding this shows you how fragile everything has become. The U.S. Space Force tracks satellites using a global network of radars and telescopes. Every day, the system measures where each satellite is and calculates where it will be over the next week. This data gets sent to satellite operators as warnings. If two satellites are predicted to come too close, one of them has to move. SpaceX fully automated this process for Starlink. Their satellites receive the tracking data, analyze collision risk without any human involved, plan the maneuver, and execute it using ion thrusters. The system runs continuously with no oversight. Satellites just dodge automatically whenever the risk crosses a threshold. Right now, the average Starlink satellite performs about 4 collision avoidance maneuvers every single month. Over its lifetime, one satellite can execute over 350 dodges. But here is the critical weakness. The tracking is not perfect. When we measure a satellite position right now, the error is about 1 kilometer. When you try to predict where it will be 7 days from now, that error grows to 8 kilometers. These satellites are moving at 8 kilometers per second, so an 8-kilometer error means the prediction could be off by 1 full second in timing. At orbital speeds, that is massive. Satellites cannot wait until the last moment to dodge. They have to move early with big safety margins because nobody knows exactly where anything will be. This is why SpaceX uses extreme caution. They trigger dodges when there is even a 1 in 3 million chance of collision. The normal industry standard is 1 in 10,000. SpaceX operates at a safety margin 300 times tighter than everyone else. This explains the insane number of maneuvers. But it also reveals how stressed the system has become. Even with 300 times more caution, the close calls are still happening. Just recently, a newly launched Chinese satellite passed within 200 meters of Starlink satellite number 6079 at 560 kilometers altitude. But with all these crazy numbers being thrown around, it's really hard to know what's actually worth worrying about versus what's just sensational headlines. And that's why I've decided to partner up with our sponsor, Brilliant. Brilliant is an interactive learning platform that helps you build real skills in math, science, logical reasoning, and much more. And honestly, what I love about Brilliant is that instead of just lecturing you, they make you work through problems until concepts actually click. Research shows that this active problem solving is way more powerful than just watching lectures or reading books. I've been using their probability and chance course to understand when numbers actually mean something serious. Like when something triples every 6 months. Brilliant teaches you to recognize when that pattern leads to disaster versus when it's just noise. And the best part is that you're already capable of understanding this stuff. Brilliant just gives you the tools to unlock that potential. Whether you're a beginner or an expert, Brilliant meets you where you are and helps you achieve what you didn't think was possible. So right now you can start learning for free for a full 30 days. And Brilliant has given my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything. Scan my QR code or use the link brilliant.org/Josh Sullivan Space in the description. At orbital speeds, 200 meters represents 13 milliseconds of separation time, 13 milliseconds between a normal day and a catastrophic explosion. And here's something that makes this even more terrifying. Our tracking systems can only see debris larger than a few inches. Right now, about 36,000 objects that size or bigger are being tracked. But scientists estimate there are 1.2 million debris pieces between 1 and 10 centimeters flying around completely invisible to radar. Each one is large enough to catastrophically destroy a satellite on impact. There are another 130 million fragments larger than 1 millimeter that are totally undetected. A 1 millimeter piece of metal hitting at orbital velocity punches through like a bullet. It can shred solar panels or puncture fuel tanks. The automated dodging systems can only avoid threats they can see. Everything smaller than 10 centimeters is invisible. We can just hope they don't hit. We saw how fragile this system is during a solar storm in May 2024. The sun released a burst of energy that hit Earth and heated up the upper atmosphere. This caused satellites to slow down faster than predicted. Over half of all low Earth orbit satellites had to execute emergency repositioning maneuvers. When a satellite maneuvers, its predicted position becomes wrong. After a maneuver, the actual position can be off by up to 30 miles compared to what tracking thinks. It takes days to update and get accurate again. Just one solar storm threw off predictions across the entire orbital population for days. The single space weather event nearly broke the whole system, and solar storms are not that rare. SpaceX has regulatory approval for 12,000 Starlink satellites, but applications pending for 42,000 total. China is planning 2 separate mega-constellations called Guowang and Qianfan, adding up to 28,000 satellites. Amazon has approval for 3,200 Kuiper satellites. OneWeb is planning 6,300 satellites in their next generation. Add these announced plans together and you get over 90,000 satellites. That is 7 times more than we have right now. If collision avoidance is happening every 90 seconds today, imagine what happens when satellite numbers multiply by 7. The dodging frequency does not scale linearly. It scales exponentially. Every new satellite creates potential crashes with every satellite already up there. The math gets ugly fast. Right now, tracking systems generate 600,000 warnings every single day. That is a 200% increase from just 3 years ago. On bad days, it hits 1 million warnings. Scientists at NASA ran computer models to see what happens if we keep launching at current rates. The models show that even if we stopped all launches today, the debris problem would still get worse. The European Space Agency just released their 2025 Space Environment Report. Even without any additional launches, the number of space debris would keep growing because fragmentation events add new debris faster than debris can naturally fall back to Earth. This suggests we might have already crossed the tipping point. We also have historical proof of how bad debris events get. In 2007, China tested an anti-satellite missile and deliberately destroyed one of their own weather satellites at 865 kilometers altitude. The explosion created over 3,000 trackable pieces and an estimated 150,000 total fragments. This single test became the largest debris field in history. 80% of those fragments are still up there 18 years later. The International Space Station has performed emergency maneuvers multiple times to avoid fragments from that test, so we know what satellite explosions create, yet we are building an environment where these explosions could start happening regularly instead of being rare accidents. The question is not if a mega-constellation collision happens. The question is when and what the first one triggers. Science shows we have 2.8 days of safety margin left. The clock is ticking, and nobody is slowing down. If you watch to the end, let me know your thoughts on all this down in the comments. Also, please click the like and hype buttons. God bless you, and I'll see you soon.